The views discussed in this conversation are the views of individuals and not of Arrington Capital. This podcast is provided solely for informational purposes and is not financial, legal, tax, or investment advice. The participants of this podcast are not recommending any particular security, protocol, token, financial instrument, or other tradable asset or any investment strategy. It is not offering to sell or soliciting to buy any security or asset.
Welcome to the Pirate Pod from Arrington Capital. We are excited to have Carter join us from QED today. QED recently closed their first round of funding to drive more growth and build a zero-knowledge execution environment for applications on Bitcoin. We're going to spend today talking about how the growth of the Bitcoin ecosystem and what the next wave of development looks like with more support for smart contracts and decentralized applications. As a developer of our podcast, we'd like to start by putting a spotlight on our founders. So, Carter, we'd love if you could give us a bit on your background, your journey to crypto, and what led you to the idea for QED.
Awesome. Thanks so much. Super happy to be on here. I'm Carter Feldman. I'm the founder of QED. I previously was in the more traditional security community. As a teenager, I was a well-known black hat hacker, then transitioned to a white hat. I built the world's most successful modding platform for a mobile game, which was for Minecraft PE, and it was called Mod PE. Later, I also developed a bunch of proof-of-stake nodes for various proof-of-stake blockchains, including the EOS network, where we were a top 21 block producer for several years, processed hundreds of millions of transactions in production. And around a year and a half ago, I started experimenting with zero-knowledge proofs. We built the first zero-knowledge proof verifier on EOS, that was compatible with CirCom, which is still today a very popular way of writing circuits. And about a year and a half ago, right around that time, I started QED.
Well, before we dive in, let's take a step back and look at what's going on from an industry perspective when it comes to Bitcoin. Bitcoin right now has nearly $2 trillion in liquidity, and the market cap is growing even today. Lots of recent news with the ETF halving. What's your take on the space and why Bitcoin over some of the more other developer-centric focus chains? If you could elaborate on your choice to build on Bitcoin specifically.
Sure. So Bitcoin is definitely the most exciting place in crypto right now. I guess for one, we sort of have this super rare opportunity where we can look back on the Ethereum ecosystem, see everything that worked, and then just bring it over to a new platform that already is seeded with this enormous liquidity. Like many have tried to deploy these newer, more developer-friendly networks, different L1s that have very little liquidity, but they're very easy to build on. We've seen them struggle, but never have we really had this opportunity to say, okay, here's $2 trillion. Let's throw DeFi at it, right? Whoever's the first to build a DeFi application on Bitcoin, they can stake their claim and acquire massive market share in a very short period of time. So it's kind of like the gold rush at this point for Bitcoin, and it's definitely the most exciting place to be in crypto right now.
So you basically see this as like the Wild West, whereas Ethereum, there's been a bit more of an establishment that's been built up around that, and a bit harder to fight for market share.
Well, there's a reason behind all of this, right? The reason why a dApp wouldn't exist on Ethereum would be because no one ever thought of it, right? But on Bitcoin, we have this additional challenge of, is it really even possible to build this application on Bitcoin, right? And if so, how? So there's kind of like a two-step process for Bitcoin, or for at least building on Bitcoin right now, which is that you first kind of have to think, okay, so how can I kind of hack this into existence? Like when people wanted to deploy tokens on Bitcoin, people took this or specifically Domo, took this ordinal spec that was used for like NFTs and embedding data on the Bitcoin blockchain and kind of hacked tokens around and sort of shoved it into Bitcoin, whether Bitcoin wanted it or not. In fact, some say they didn't, but regardless, it's just kind of this age of experimentation, and whoever can figure out how to get it to work is able to acquire this massive market share very quickly. And for people that love technical challenges like myself, previously being a hacker as a kid and wanting to experiment and toy with things and make things happen that perhaps shouldn't be happening in certain games, in certain contexts, working within these constraints is actually a pleasure. and I enjoy it immensely. So Bitcoin is definitely the best place for me, and we think it's the most exciting place in crypto.
Okay, so let's maybe talk about what QED is. Can you tell us a high level what you're building and how it solves some of these technical challenges that you just mentioned?
First and foremost, QED is a horizontally scalable layer 2 on both Bitcoin and Ethereum. We support all the dApps that you'd want to have on normal chains like AMMs, stable coins, DAOs, the works. But in addition, you can build some really, really exciting horizontally scalable applications on QED as well. So that means you got order book exchanges with trading pairs that can operate at several thousand TPS per trading pair. So you can have that full centralized experience with the security of a DEX rather. And then, in addition, we're working with a bunch of game partners to build some really cool Web3 gaming applications on QED that just aren't possible anywhere else. And with regards to Bitcoin, QED made a strategic decision in autumn that we really wanted to pursue Bitcoin. We thought this is the most exciting opportunity probably for most of our natural lives. And we thought that, Bitcoin would be a great home for QED. And we set aside a task force within the company that just researched Bitcoin 24/7. We started building Bitcoin developer tooling. We built BitID, which is currently the world's most used by monthly active users, Bitcoin tap script ID. So if you're going to script directly on Bitcoin, right now BitID is the place to be, and we built that in just a few months. We built a one-click, one-liner startup to start up a local testnet for Bitcoin nodes, which had really been hampering. If we look through some of the Bitcoin talk forums, a bunch of that stuff, you could see people were really struggling getting the local testnet started. We now changed it so anyone could do it with one line. We also built the L20 ordinal standards, which enables QED to become a layer 2 on Bitcoin. And we open sourced a bunch of that. We're going to be open sourcing the rest of it. And essentially for the past few months, we've had QED in a pretty ready state and have just been, preparing that glue to make it work on Bitcoin, which has manifested itself in our L20 Ordinals Consortium. And we've gone and shared that technology with the rest of the ecosystem.
Okay, well, there's a lot to unpack there, so I'll try and chunk this into a few pieces. The first thing you mentioned was that you're a layer 2 on both Bitcoin and Ethereum. Can you tell us what exactly you mean by layer 2? Because it seems like everybody's calling themselves a layer 2 nowadays, but there's a lot of different ways that they're accomplishing that, or things that even means.
Yeah. So in our eyes, what a layer 2 means is that you built some platform, some application platform that inherits the security of another application platform. So I build a blockchain that has the same security as Ethereum. And how does it inherit that security? Well, in the case of QED, we use zero knowledge proofs. So essentially we generate a proof that some transactions have been executed correctly. And then we verify that on a compute platform that is super, super secure, like Ethereum, like Bitcoin, right? So in our eyes, this is what a layer 2 is. Of course, this means that by this definition, that optimistic rollups are not layer 2s, that multisigs are not layer 2s. But we think that, if you're just a multisig or an optimistic rollup, the connection between the layer 1 and the other chain is quite loose. And for that reason, perhaps they're not layer 2s, but at least for us, it's very important that we inherit all the security of both Bitcoin
and so when you say you inherit the security of both Bitcoin and Ethereum, does that mean you have the security of whichever one is least secure, or how exactly does that work?
No. So to break QED, you would have to break both the security of Bitcoin and the security of Ethereum.
And can you walk us
right?
Yeah, can you walk us through how that works?
Sure. So essentially, the way that it works is whenever we produce a block proof, we send that proof to both Bitcoin and Ethereum where they're verified, right? Now, Bitcoin verifies the proof, right? It has the verifier data baked in there. The same thing is true with, the Ethereum chain. So let's say you compromise the Ethereum chain. The only thing I would be able to do is input, compromised ERC20 tokens into QED, but QED itself would still work on Bitcoin. So even if one day all of the Ethereum nodes shut down and it was all gone, it would still work on Bitcoin, because Bitcoin is still going to require you to submit proofs that adhere to the correct, let's say, proof verifier key for QED. So the only way to topple QED is to topple both Bitcoin and Ethereum. And, if Ethereum, again, maybe some weird US government thing, you never know, right? Maybe a lot of Ethereum nodes go down, we will be okay. And we're throwing our lot in with Bitcoin very, very heavily. So we'll think QED will be very secure into the future.
Okay, well, let's now transition to talking about how you're actually doing this verification on Bitcoin. Because Bitcoin doesn't have the same kind of Turing complete smart contract platform as Ethereum, and that's what creates a lot of this technical challenge in the first place that I think you were referencing earlier. Can you walk us through how you're accomplishing this?
So our approach was twofold. On the one side, for all of our block proofs, we use the L20 Consortium official ordinals indexer to index all of the different zero knowledge proofs. And then we also have some special magic that we've been working on with some very large partners in the ZK space that enables us to do the trustless peg in and peg out for Bitcoins coming to L2 and then back again to L1.
And then Bitcoin is super cost intensive to really do anything on the blockchain. And we've seen these costs skyrocket as after the creation of ordinals, as demand for block space has increased. Can you talk to us about what kind of effect QED will have on demand for Bitcoin block space and whether it's going to be expensive for users to use your chain?
So first of all, the cost of Bitcoin the cost of Bitcoin transactions doesn't affect the cost of transaction on QED. And the reason for that is that when we actually send that zero knowledge proof off to Bitcoin, its size doesn't depend on the number of transactions that it's proved on QED. So we can have a proof with 1 million transactions in it and a proof with 10 transactions, and the proof size is exactly the same. And the difficulty of verifying it is exactly the same. This is the magic of zero knowledge proofs, right? So it genuinely won't affect that. However, QED's efforts, specifically with our L2 ordinals or L20 Consortium, what we're advocating for is essentially that we take all of those BRC20s, your ordinal NFTs, your ARC tokens, your runes, whatever, take them, move them into layer 2s, take those transactions off chain for the vast majority of situations, and we give also a BRC20 backwards compatible path so that you can take your tokens, deposit them in layer 2, do DeFi, the works, everything that you want to do, and then you can always withdraw them back to layer 1. So we actually want to reduce the cost of Bitcoin block space by reducing the amount of ordinal transactions and moving those into a 500 byte proof. So you can kind of think of it as we take all the megabytes and megabytes of ordinals transactions and compress them into 500 bytes. And because of the magic of zero knowledge proofs, you can actually do that. So transacting on QED going to be super, super cheap. We let our users prove their own transactions. You get a fixed or an infinite number of transactions for a fixed fee, which is pretty cool, right? If you want to do payroll on chain, we start with 10 people on payroll. Maybe your company does well. You got 2,000 people on payroll. You're going to be enjoying that, unlimited transactions for a fixed fee quite well as a user, I would imagine. So yeah, fees on QED going to be super cheap. And at the same time, just by the very existence of trustless layer 2s on Bitcoin, it's going to reduce the demand for ordinals. Ordinals are going to be moved onto layer 2. And I think it's a win-win for both the Bitcoin Core OGs who aren't very happy about ordinals, and a win-win for the users, because not only can they continue to issue tokens on Bitcoin, trade tokens on Bitcoin, but they can also unlock all of the utilities that you get with smart contracts. So it's really a win-win in the fullest sense of the word.
Got it. So I think you did a good job of explaining how it's cheap on Bitcoin once you've actually got the zero knowledge proof that you're publishing. Uses a fixed size and fixed amount of compute to do the verification. But I think what we could talk about a bit more is how you actually accomplish the scalability and speed for the proof generation. You mentioned that users are able to generate their own proofs, which for somebody who's more familiar with existing like layer 2 solutions on Ethereum that are built around the EVM, listeners might know that a lot of those projects have to use specialized hardware to generate the proofs, and it's very compute and energy intensive. And so how are you getting this so that the user can generate the proof on their computer or their phone to submit to your network?
For sure. Well, the first key is not building an EVM. So the way that zero knowledge proofs work is generally you want to be doing all of your arithmetic, your adding, subtracting, multiplying, dividing, all that good stuff. You want to be doing it in some prime field, right? Rather than using the uint 256 registers that you're using with Ethereum. So just essentially every operation is just vastly more expensive. And we end up with these monster VM cycle circuits in various EVMs, which just means it takes a lot longer to prove. How much longer? About several orders of magnitude. So let's say 16x, something like that. And the difference between or 16x is actually a very, very noticeable UX breaking feature. So for instance, our prover to prove a transaction takes about 100 milliseconds, right? So 100 milliseconds is like a couple of blinks, right? And 100, or maybe just one blink, right? In a blink of an eye, your transaction is ready. 1.6 seconds is quite a few blinks, right? It's like a frozen browser window waiting to prove, right? So yeah, like just designing a ZK native blockchain, essentially, we've designed an entire blockchain around zero knowledge proofs. Perhaps we're the first ones to do this with global state. But yeah, so that's just really what makes like the prover fast enough to be able to run on machines, is that we're writing code, compiling code to bytecode that is really heavily optimized for zero knowledge proofs. In addition, what gives us horizontal scalability is our radically different state model than everyone else. So as you're proving transactions on QED, you're making modifications to isolated state trees that only you as a user are able to write to. And I can read from all the other users' state as it was at the end of the last finalized block. And this pattern allows us to have hard guarantees against race conditions between users during a block. And what does that mean? That we can process, verify all of their transactions in parallel. So what we do is we build a proof tree. We're going to be recursively verifying 4 of those users and then connecting them in the global state tree to their nearest common ancestor. So you can imagine we have this big triangular looking tree, right? And there's a bunch of nodes in the tree. And we start by proving the individual user nodes at the bottom. And then we work our way up until we're at the very top of the tree. And we prove that this one node, which represents the entire global state of the chain, has mutated from its previous value to a new value. And we generate a zero knowledge proof that proves all of that and again, like O of log n time. So that's what horizontal scalability essentially means, is O of log n time, and we've done it. So that means, just to put that in numbers that make sense for people, a million users transacting at the same time, sending off a proof. Maybe each user does 3 or 4 transactions. We got 3 or 4 million total transactions being processed in something like 6 seconds. So a 6-second block, that's like 500K TPS. So it's great.
Got it. And you guys have O of log n time because you have a tree that is binary, so each node has 2 children. And then at the bottom you have all of the
It's a
leaves
quad
of that
tree.
tree.
It's a quad tree, so it's actually log base 4. It just happens that because of the way that it has to do with, you can imagine if you have some zero knowledge circuit and there's some verifier key that you need to encode in something like lookup or some kind of a lookup, like doing multiple proofs at the same time makes sense. Some things can kind of be batched together. But yeah, so we do 4-to-1s. So it's log base 4 of n times the proving time, which is about 300 milliseconds to take 4 proofs and compress it into 1.
Cool. And you mentioned that this is a different state model than what currently exists. What does that mean for application developers? How is this going to be different and maybe more efficient than previous state models, like what you see with the EVM?
We have tons of wonderful tooling built around this state model. So you can do really cool things like ZK map reduce. You can build like these atomic counters, which act like normal transactional database queries. So for Web 2 developers, they should actually feel way more at home on QED than they would on something like Ethereum. For Web 3 developers, you've got to learn the scalability sort of practices that everyone uses in the Web 2 world, because no one's building a website that only 10 people can use at the same time, right? So the tactics that you use to build a website are very different than the tactics you use to build Uniswap, which is a wonderful application. We love Uniswap. But if you wanted to build a Uniswap that could scale to 1 million users, well, you would have to have some different decisions on how you model the state of the application, right? So like for people that are CS grads coming out of school, QED will feel right at home with what they've learned. And we're also trying to get QED in the curriculum as well. So maybe it'll really feel right at home after graduation. But yeah, so QED, I would say for the developer experience, we're miles ahead of the rest of the pack, far better than EVM. You know, we support, for instance, vanilla ES6 JavaScript. The amount of tooling that has been built around JavaScript is truly insane. It's one of the largest, I guess, accumulation of human effort kind of projects that has ever existed. So yeah, we are definitely plugging straight into that.
Nice. And do you support just JavaScript, or will you be able to support multiple languages?
We are in fact VM agnostic. So we support JavaScript, Python. We're focusing on those 2 languages to start, just because they're the world's most popular programming languages. But, you know, we'll support EVM that has like a altered state model. We're working with some partners at OLAVM actually on that. Wonderful team there, you know, great builders, I believe, also based out of Asia. But yeah, so we'll be supporting your EVM, Rust, C++. Right now we're working on recursive verifiers for both RISC-0 and SP1. You know, we don't know who's going to win the sort of risk wars that's going on right now. So we're writing recursive verifiers for both. We already have a recursive verifier that works so you can write your contracts in Polygon Maiden. We love the Maiden team. Shout out to Bobbin. But yeah, so really, you should be able to build with whatever language or stack you want on QED. We've just focused on getting compatibility for JavaScript and Python ready for launch, so that when we launch, we can take advantage of the largest coding communities.
Gotcha. And how are you able to accomplish this at a technical level? Like if I'm in, just for my identification too, if I build a contract in Python, and I want to be able to somehow make that composable with the contract built in JavaScript, is that going to be possible?
That is the magic of what we call the dApps ABI. So for each contract, you actually first specify this ABI that sets out, okay, what functions am I exposing to the world? And what is the state topology of, you know, my storage, right? So we have this generic ABI, or application binary interface, that tells JavaScript how to call any other contract, whether it's written in Python or some other language. And in fact, we also allow you to first just write out this ABI where you just sort of put like the call, like, you know, you can imagine like the arguments to a function and the return data of the function, and then also just model like the struct of your application as you would kind of like with the state information and something like a JavaScript or a Python class. And then after that, I can click a button to generate a JavaScript boilerplate contract or a Python boilerplate contract, or soon a Rust and a C++ boilerplate contract. And we can actually go directly from ABI to code. So yeah, like the way that the Python and Rust contracts, for instance, could talk to each other is, again, since we have this like standard calling convention, it makes it really easy, and in fact, automatic for certain contracts if they publish their ABI, to just like reference a contract by its contract address, and then magically our IDE auto imports all of the type information for it, and you can just call away.
Can you, at a very high level, just remind us what the L20 Consortium is and why you're starting it?
Absolutely. So the L20 Consortium is a group of layer 2s and other people in the Bitcoin ecosystem that are setting the standards for Bitcoin's native execution layer. And Bitcoin's native execution layer is clearly going to be zero knowledge proofs, since we have a very limited VM. And right now we've got the likes of Starkware, ZKLink, Mina, big projects that have raised hundreds of millions of dollars. As a group, over $1 billion. And essentially, we are the largest force within the Bitcoin Layer 2 ecosystem, and we're welcoming new members all the time. And ultimately, we're just here to set those common standards so that as a Bitcoin user, I could go and bridge in, use a Layer 2 application, be doing DeFi on Bitcoin, participating in DAOs. Maybe I've got my NFT collection, and as a Bitcoin user, all of these transactions feel like normal Bitcoin transactions. I don't feel like I'm using some weird Layer 2. I don't have to install some new application for each Layer 2 that I interact with. Instead, I'm just using the Bitcoin L20 client. So we're just trying to be the sort of both lobbying group to get Bitcoin users to start using Layer 2s, and also the standards commission that really is setting the technical standards that will make Bitcoin Layer 2s as accessible as Ethereum dApps are for Ethereum users.
Got it. And you mentioned at the beginning of that answer that you thought that it was obvious that ZK is the way that people are going to go for building Bitcoin L2s. But there are hundreds of Bitcoin L2s being built right now, and most of them are not ZK. So
yes,
that might be a minority opinion at this point. Why do you hold that so strongly?
Okay, so first of all, Bitcoin has a fixed block size. Anyone who knows the Bitcoin history will know that there was this big event called the block size wars, right? Where this fork of Bitcoin called Bitcoin Cash wanted to become predominant and increase the Bitcoin block size so we can have more transactions per block. This resulted in mass chaos, the creation of many Bitcoin forks, and ultimately a consensus that the blockchain would not be increased. So if we want to build Layer 2s on Bitcoin, we need to be working within a very small amount of block space, because this question has already been debated to heal, and we know that we're not getting more block space. So we're not going to be doing any dank sharding on Bitcoin, right? This is not going to be happening. Now, with a fixed amount of block space, if we want to support 1 million transactions per second, inheriting the security of Bitcoin, there is only one solution there, which is zero knowledge proofs. Because again, I can do 1 million transactions and get a 500 byte proof, right? So I can get a lot of 500 byte proofs from a lot of L2s if we're working with 4 megabytes, right? This is not a problem. But if we're talking about doing optimistic rollups where I need to have my DA on Ethereum or on Bitcoin in this case, the storage size is going to scale with your usage. So if you have a bunch of users coming on your Layer 2, that just means a bunch of clutter on the Bitcoin L1, right? So you're not going to, maybe you could have one roll up on Bitcoin and take the whole block space. And where does this leave us? Well, now we've just supplanted Bitcoin with something else, and we haven't scaled anything. Perhaps it's even less efficient, and we're kind of back to where we started. So it's very clear that the only serious solution in town for people that value their security is zero knowledge proofs. I mean, you could do a multi-sig, But a multi-sig is just kind of like me saying, hey, I've got a group of my friends, and whenever you want to do a transaction, just first give me the money, and I'll keep an Excel spreadsheet with me and my friends. It's a group document. We can all edit it, right? I'll keep a spreadsheet, and I'll make sure to update your name. And so when you want to send money to Paul to give him a Christmas present, right, just tell me, and I'll process it for you. And if one day you come along and, maybe, you accidentally slighted me, right? You accidentally slighted me. I close my book. The Excel document is closed. It's password protected. You have no access to it. I've decided, maybe the U.S. government puts you on some list, right? You're out of here, right? You're not able to transact anymore. And this is essentially what the multi-sigs are. So for Bitcoin users who already were kind of opposed to banks, which at least have to follow some legal rules around making the money that you deposit accessible to you, right? Otherwise, you can make an FDIC claim, right?
Even in the U.S., I was going to say, even in the U.S., we've seen at certain times in history, the government come in and work with the banks to just clear out people's safety deposit boxes. But
at least they're not as capricious as some group of anons that started a cryptocurrency, right? Like, I would say I trust the U.S. government more than I do a random person on the street. Perhaps this is controversial as well. But regardless,
I guess it depends on whether that person has the record of the government. But yes, I know what you're saying. But the multi-sig approach is basically
is less safe than putting your money in the bank.
Yeah, it's the trust me bro approach.
Exactly. So we are not fans of the trust me bro approach. And the thing is with Bitcoin users, that I think is very different than Ethereum users, which is that Bitcoin users tend to be more ideological. A lot of people bought Bitcoin because they wanted to have some assets that are not in the control of any other human being, right? Something that really belongs to them. And so when you ask them to just trust me, bro, there's some self-selection that has gone on within the Bitcoin population, is what I'm trying to say. These people are perhaps less trusting than, the normal or the average person, right? So we need to give them a solution that preserves the security of Bitcoin. And as I was mentioning, the only really way to do this is with zero-knowledge proofs.
Okay. And I just want to make sure we finish talking about the L20 Consortium as well. Why are you so focused on contributing to open source Bitcoin standards? And how is that going to lead to the further success of QED?
For sure. So, first of all, we've gotten this question a lot. Investors have asked, why do you publish anything, right? Stop open sourcing things, right? This is your secret sauce, right? This is your moat. Well, what keeps me up at night is not what percentage of Bitcoin's, $1 or $2 trillion of liquidity, what percentage of that will end up on QED. That's not what keeps me up at night. What keeps me up at night is, will Bitcoin users use Layer 2s? Will they trust them, right? Will they want to earn interest on their Bitcoins? Will they be aware that they can deposit money on Layer 2s and earn interest on their Bitcoins? So for me, this is what keeps me up. And the antidote to this is to inform the Bitcoin users of the trustless zero-knowledge Layer 2s on Bitcoin, and to build trust around some kind of a brand or some kind of a differentiator between the ZKP-based trustless Bitcoin Layer 2s and the trust me bro, multi-sigs that we have going on. So in order to do this, it's not so difficult to see how this could be done. It's essentially just marketing dollars. Now, we're a small startup, right? We don't have that much money to spend on marketing. And what better way to alleviate this problem than to bring on some of the largest industry leaders within the blockchain space, have them join us as peers at a standard stable, and under our rubric or our original draft, set out the standards that everyone can use, so we can band together as a large group and lobby Bitcoin users to start using Layer 2s together rather than competing with each other. So I think this kind of collaborative sort of approach kind of only works in crypto. Usually people are very, cutthroat with their so-called competitors. But yeah, in crypto, we believe in kumbaya, we believe in linking hands, and I think we'll be able to convince the Bitcoin users as a whole to come start using layer twos because of the work that we're doing at L20. So yeah, we're not worried about QED's market percentage. We're more worried about the Bitcoin community's attitude towards layer twos as a whole. That's what keeps us up at night, and that's what we're working every day.
Really reinforces the fact that you guys are trying to align yourselves with the original ethos of Bitcoin and why it was created in the first place, and making sure that however we do add utility to it, it's still in alignment with the Bitcoin maxi community as well, which I think would definitely prefer the zero knowledge approach, and what you guys have been advocating for just in terms of block space usage and inheriting the actual security of Bitcoin versus these other approaches. If you could let us know what's next in the pipeline and what you're working on at QED, maybe a little bit about your roadmap or some teasers, if you can share anything with our listeners.
Yeah. So we've got TestNet coming very soon. We're targeting the halving as our date, but the team has been expanding a lot recently. Onboarding people does take time, so we'll see about that, but that's our tentative date, at least that we're aiming for. Collaborations with large IPs, movie studios are coming quite soon. Announcements of our collaboration with your favorite blockchain, if we look just statistically on average, or at least your favorite layer 2, is definitely coming. Some really cool collabs with Bitcoin Magazine are in the pipeline. Also, shout out to r/Bitcoin Dev. We're building a Bitcoin developer community. That's definitely coming. New updates to BitIDE to support different kinds of signature schemes and make it easier for people to build in TypeScript on Bitcoin. There's a lot to come. The next couple months will probably be some of the most exhausting, but hopefully the most productive months in the life of QED. So we're very excited.
All right, fantastic. And where's the best place to keep up with QED and what you guys are building?
Definitely x.com/QED protocol is the best place. And you can always follow me at CMPEQ. That's CMP, like compare, EQ, equal. Yeah. The ARM instructions.
Great. Do you have any closing thoughts, Carter, on QED, where Bitcoin is going, and what you're most excited for over, let's say, the next 3 years in the Bitcoin ecosystem?
So this summer is going to be the summer where a lot of these applications that people have started building on Bitcoin are going to be launched. And suddenly, for the first time, Bitcoin users are going to have access to all the stuff that Ethereum users and Solana users and all those people have had access to before. And it's just going to be this Cambrian explosion of really cool applications and developers and users.
Arrington Capital is really thrilled to be a part of supporting you as you go forward. We look forward to all of the innovation coming out from you and your team, and all that you're going to do for Bitcoin and the crypto ecosystem more broadly. Really appreciate you joining us. Thanks for coming on, Carter.
Thanks so much, Colton.